My name is Katie Moorhead. My partners are Thomas Inzer and Carrie Howard, and we are investigating how variance in currents affect the rate of electroplating. We're testing to see if Faraday's law is correct. Electroplating is a process that uses electric currents to reduce dissolved metal cations so that they form a metal coating on an electrode.
Our area of focus is to look and see how much mass each spoon accumulates over the time it soaks in the solution.
So change this number of volts, so change the number of volts, increase the current going through here, and we read that on this ammeter, which is so, and we currently have it set on 50 milliamps, so we're reading it, so the max reading you can get is 50 milliamps. And so then, as we increase the voltage, we'll increase the current going through and thus increase the amperage.
Okay, and then right here we're going to connect the copper, and then there is going to be...
Yeah, so right now this is just to make the circuit.
Okay, and so we're going to be using a spoon instead,
yes,
right?
we'll be using a spoon. That's just to make a circuit.
So the spoon is going to be where the nail is, and then the copper will...
The copper wire will remain the same.
So we had too many wires and clips in our solution, so now we're using a nail because that's going to be easier to stick in.
What we're doing, so for our procedures for this experiment, it's pretty basic. So we have a spoon, which is not going to be electroplating. So we cleaned it with some toothpaste to make sure, all the grease, all the stuff is off. And then we would get a piece of cardboard, punch the copper wire, which is serving as our anode, the spoon through it, so that way it could be suspended in solution. Put that in solution, we would turn the power supply to set to the voltage, which would either be 0.5, 1, whatever, 2 for whatever test we were doing. You would then attach the positive lead from the power supply to the anode, which would be the copper wire in this case, and then we attach the the cathode, which would be attached to the spoon in this case, and then we would turn the power supply, leave it for 20 minutes, and then we'd come back, take it all out, and it's being plated. And so we chose stainless steel spoons mainly because they're just really easy to get a hold of. And the same as for toothpaste. Toothpaste is a abrasive cleaner, which is what you really need to clean the surface of the spoon. And so it serves any metal you're plating. And we chose it because it's a abrasive cleaner, it's not toxic, really easy to get a hold of, really cheap. But our choices did lead to some problems, mainly that with stainless steel is kind of hard to get material to stick to it. So if you want to have a really good plating, we would probably use something else besides stainless steel. And then we tested a nail, which is zinc plated, but for some reason that didn't work. She needs some more research for that. And so then in order to deal with the spoon, we only plated a small part of it that way. We want to plate the whole spoon, get a better result. And then we had a couple issues with our first trial, so we had to end up starting over. And so,
a new question that arose from our experiment is what materials would be better for this experiment besides stainless steel? Like what would plate better? And in conclusion, our hypothesis was So in conclusion, our hypothesis was proven correct, and the next step in this project would be to test other materials besides stainless steel.